You ever stop and think about how your computer can be streaming a movie, downloading emails, and letting you browse the web, all at the exact same time without getting everything tangled up? It really does feel like magic, but it's not. It's actually a brilliant system working just under the surface. All right, let's pull back the curtain on the internet's invisible digital mailroom.
Really think about it. When data hits your computer, it's all just a jumble of ones and zeros. So how in the world does your device know that this chunk of data is the next scene in your movie and not the text from a new email? How does it all get sorted to the right place?
Well, the answer lies in a part of your computer's networking system called the transport layer. And the best way to think about it is as this super efficient, totally invisible mailroom running inside your device. It's the critical go-between that connects the apps you're using to the huge global network of the internet. It makes sure every single piece of data gets to exactly where it's supposed to go.
So what's this mailroom actually doing? Well, its main job is to juggle all the different conversations your computer is having at once. It takes big chunks of data from, say, a website and chops them up into smaller, numbered packets, kind of like putting parts of a big order into separate, numbered boxes. And then it makes sure they all get put back together in the right order on the other end. It's the master organizer of your digital life. Now, this digital mailroom doesn't just have one way of sending things. It actually offers two totally different kinds of delivery services, and it all depends on what's being sent. Think of it like this. You have to choose between sending a super reliable package with tracking and delivery confirmation, or just tossing a quick postcard in the mailbox.
And these two services have names you might have heard before: TCP and UDP. TCP, which stands for Transmission Control Protocol, is that reliable option. It's your certified mail. It guarantees delivery. Then you have UDP, or User Datagram Protocol. That one is all about speed. It's the postcard. Super fast, super simple, but no guarantees.
Okay, so let's dig into TCP first. This is the reliable workhorse of the internet. Whenever you absolutely, positively need every single bit of data to arrive perfectly and in the right order, you are going to use TCP. So let's see how it pulls that off.
The secret to TCP's reliability is that it's connection-oriented. Before it even thinks about sending a single pocket of data, it establishes a formal connection. It's basically like making a phone call to say, "Hey, I'm about to send you a big package. Are you there? Are you ready for it?" This little setup makes all the difference.
This phone call is a super fast three-step chat. First, your computer sends a little message, a SYN packet, that says, "Hey, can we talk?" The server on the other end replies with a SYN/ACK, which means, "Yep, I'm here, I'm ready." Finally, your computer sends one last message, an ACK, that says, "Awesome, let's do this." It's this simple agreement that makes sure both sides are ready before any data gets lost in the ether.
And this is where TCP gets, a little obsessive, but in a good way. It acts like a meticulous shipping clerk. It slaps a sequence number on every single packet so they can be put back together in the right order. It waits for a delivery receipt for every packet it sends, and if that receipt doesn't show up, it just sends a replacement, no questions asked. It even checks to see if the other end is getting overwhelmed and will actually slow down to prevent a traffic jam. That's what we mean by guaranteed delivery.
All right, let's hop over the other side of our mailroom because things are about to get a lot faster and a little more reckless. If TCP is the careful, by-the-book courier, then UDP is the total speed demon. Its whole philosophy is basically fire and forget. UDP is the complete opposite of TCP. There's no three-way handshake. There's no connection. An app using UDP just starts blasting packets out towards the destination. No hello, no how are you. It just starts sending.
This best effort approach is exactly like our postcard analogy. You write it, you drop it in the mail, and you just hope it gets there. There's no tracking number, no delivery confirmation, and you're definitely not getting a call if it gets lost. So what's the payoff for all this risk? Oh, it's simple. Speed. It's incredibly simple, light, and just fast.
Okay, so you're probably thinking, why in the world would anyone use a delivery service that isn't reliable? And that's a great question. But it turns out that for a lot of things we do online, speed is way more important than perfect 100% reliability. Let's look at some real-world examples.
This is where you really see the trade-offs. For something like an email or a file download, you need every single bit. Missing one part could corrupt the whole thing. That's a job for TCP. But what about a live video stream or online gaming? Speed is everything. A single dropped pixel is a tiny glitch you won't even see, but you will notice your video buffering while it waits for a resent TCP packet. That's why video streams and online games, where every millisecond counts, almost always choose UDP's raw speed.
Okay, so we know how the data gets from one computer to another, either reliably or super fast. But we still haven't quite answered that first question. Once the mail arrives at the right building, how does the mailroom know which specific apartment to deliver it to? How does it find your browser instead of your email app?
The solution is so simple and elegant. Port numbers. If your device's IP address is the street address of the entire apartment building, then the port number is the specific apartment number inside. Every application running on your computer is listening on a different port, its own unique mailbox waiting for its delivery.
And we're not talking about a small building here. This digital mailroom is like a skyscraper with, get this, 65,535 possible mailboxes, or ports. And it's that massive number that allows your one computer to have dozens of separate conversations, your game, your browser, your music stream, all happening at once, without a single piece of mail ever going to the wrong door.
And some of these port numbers are basically famous. The first 1,000 or so are called well-known ports, and they're reserved for standard services. So when your web browser wants a web page, it knows to send a TCP request to port 80 or port 443 for a secure site. Your email app knows to talk to the mail server on port 25. These standards are what make the internet just work.
So after all that, let's just zoom out for a second. Why does any of this techie stuff actually matter? Why should you care?
Well, because every single thing you do online depends on it. The transport layer is this silent, unsung hero working 24/7 to sort, manage, and deliver trillions of packets of data every single day. It's the master coordinator that lets your one internet connection become a gateway to countless different experiences all at the same time.
Without this organized mailroom, the internet would just be pure chaos, a fire hose of data with no direction. It provides the essential structure that allows the software on your computer to talk to servers all over the world in a way that actually makes sense. It's the bridge that makes it all possible.
So I'll leave you with this. The next time you hop on a video call, or you load up a web page, or you jump into an online game, just think for a second about what's happening under the hood. Are you sending fast, fly-by-the-seat-of-your-pants postcards, or slow but guaranteed certified mail? The cool thing is, now you know.